Hello, welcome to Math. Prove that integral sine x dx equal to minus cos x plus c. Let's write our solution. Now let's repeat this one. Here we are going to do substitution. Okay, so substitution. You let u equal to sine x. Okay, so let's write. Here we are going to take sine inverse of both sides. We will take sine inverse of this and also take sine inverse of this. Okay, so take sine inverse of both sides. Now sine inverse of u will give us sine inverse of u, and sine inverse of this one will give us sine inverse of sine x. Okay, so let's write. Now sine inverse of sine x will give us what? X. So this one will be equal to this one will give us x is equal to sine inverse of u. Okay, because here sine inverse of this will give us x, and then this one we just maintain it as it is. Okay, so we are going to get x is equal to sine inverse of u. Okay, so let's write. Here we are going to differentiate. Okay, so differentiate. Now when you differentiate x, we are going to get dx. When you differentiate sine inverse of u, we are going to get 1 over square root of 1 minus u squared du. Okay, so let's write. Now let's put this one into the integral and then let's continue from there. U times 1 over square root of 1 minus u squared. That will give us u over square root of 1 minus u squared. Okay, so let's write. Here we are going to do another substitution. Okay, so substitution. We will let m be equal to 1 minus u squared. Okay, so let's write. Here we are going to differentiate. So differentiate. Now when we differentiate m, we are going to get dm. When we differentiate this, we are going to get minus 2u. Okay, so let's write. Here we are going to divide both sides by minus 2u. You divide this one by minus 2u and also divide this one by minus 2u. Okay, so let's write. Now here this minus 2u will cancel out with this minus 2u, leaving the u. So we are going to get du is equal to 1 over minus 2u dm. Sorry, du is equal to 1 over minus 2 dm. Okay, so let's write. Let's put this one into the integral and let's continue from there. Now u over square root of m times 1 over minus 2u dm. Here this u will cancel out with this u, and this minus half here, or 1 over minus 2, can be written at the back here. Okay, so we just bring 1 over minus 2 outside here and then we integrate what is inside. Okay, so let's write. One over square root of m. Here to integrate, we are going to apply the negative index law of indices. That is, 1 over a can be written as a raised to the power minus 1. And this square root of m here can also be written as m raised to the power half. Okay, so when we apply the negative law of indices, we are going to get m raised to the power minus half. Okay, so we are going to get minus 1 over 2 integral m raised to the power minus half dm. Okay, so let's write. Here, to integrate this one, we add 1 to the minus half, and then we divide it by minus half plus 1. Okay, and then we multiply this minus half outside here. Okay, so let's write. Now, when you add 1 to this minus half here, we are going to get half, and that is m raised to the power half. And here also minus half plus 1 is going to give us half, that is 1 over 2. Okay, so let's write. Minus 1 over 2 into bracket m raised to the power 1 over 2 over 1 over 2. Now here, these two here, we'll just come and multiply this m raised to the power minus half. Okay, and remember, m raised to the power minus half can also be written as square root of m. Okay, so we are going to get minus 1 over 2 into bracket 2 times square root of m. Okay, so let's write. Now here we are just going to open the bracket. Okay, so open the bracket. Minus 1 over 2 into bracket 2 times square root of m. Now when we open the bracket, these 2 will cancel out with these 2, and that will give us minus square root of m. Okay, so let's write. Now we are done with the integration. We have to go back to the x world, but we know that m is equal to 1 minus u squared. Okay, so let's put that one here. So m is equal to 1 minus u squared. So we are just going to write this one here. Okay, so let's write. One minus u squared. But remember, we also know that u is equal to sine x. Okay, so we are just going to put sine x here. Okay, so let's write. But u is equal to sine x. So we are just going to put this sine x here. Okay, so let's write. Minus into bracket 1 minus square root, minus into bracket square root 1 minus sine squared x. Now using trig identities, that is sine squared x plus cos squared x equal to 1. Okay, so when we make cos squared the subject, we are going to get 1 minus sine squared x. Okay, so having 1 minus sine squared x here can be equated to cos squared x. So instead of maintaining this one here, I'm just going to replace it with cos x squared. Okay, so let's write. Now when you take square root of cos x squared, you are going to get cos x, and then we multiply it with this one, and that will give us minus cos x. Okay, so let's write. Therefore, integral sine x dx is equal to minus cos x plus c. So let's write. Therefore, now the workings from above tell us the reason why when we integrate sine x, we get minus cos x plus c. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.